Hi everybody. Today in this presentation I want to analyze what is coma, how can we eliminate the aberration coma. Before discussing about the coma, we want to remember what are chromatic aberrations, what are monochromatic aberrations, how many types of monochromatic aberrations are there. We know monochromatic aberrations is such that if the object is monochromatic, that is single color, the image is not a perfect image. This kind of defect is called monochromatic aberration. We know the monochromatic aberrations are five types. One is spherical aberration, and second one is coma, third one is astigmatism, fourth one is curvature, and fifth one is distortion. So these five defects forms different types of images for different types of objects also. In case of spherical aberration and coma, it produces blurring of image. It produces blurring of images. In case of astigmatism, curvature and distortion, the image is dislocated. So these are the main features of the monochromatic aberrations. Now what is coma? In case of spherical aberration, the point object is placed on the principal axis. Always it is not possible. The point object cannot place it on the principal axis. If the point object is slightly off the axis, then what happens? If the point object is slightly off the axis, then the image is formed like a egg shape or comet shape. Comet is nothing but in Telugu తోక చుక్క. So the image is like a comet shape. తోక చుక్కలా కనిపిస్తుంది. So this defect of the image is called coma. So when the point object is slightly away from the axis, the image of the point object formed by the lens is found to have a comet shape or egg shape. This defect in the image is called coma. As shown in the figure, this is a convex lens. So A, that is the principal axis. An object, point object A is placed slightly away from the principal axis. Then the rays will move and incident on the convex lens. We know convex lens can be divided into different circular zones. So these rays will pass through the different zones and incident on the and form an image at the screen. There is 1 1, 2 2, 3 3, and 4 4, etc. are the circular zones of the lens. Rays which is passing through the zone 1 1 is formed an image I1 on the screen. Thus image is just like a point image. If the rays which is passing through the second zone, 2 2 zone, these rays is incident on the screen and formed an image I2. The image is also not a point image. This is in circular shape with have some small radius. And the rays which is passing through the third zone, that is 3 3 zone, the image is formed at screen at I3. The radius of the I3 is more than the image of the I2. Similarly, the rays which is passing through the fourth zone, whose radius is very much. So, if we observe this type of image, this is like a comet. So, this kind of aberration is called coma. Now, why this coma is existing in the convex lens, whatever it lens? So the defect arises due to the following reasons. Different zones of the convex lens having different lateral magnification. Different lateral magnification is nothing but different zones having formed different sizes of images. So that if the radius is very small, the size of the image is very small. If the radius of the circular zone is very high, the radius is very high. And if the radius is further increases, the radius of the image will further increases. So different zones of the convex lens having different lateral magnification. This is one of the reason to arise Coma defect. And second one is each zone forms the image of a point in the form of a circle, because in a lens the circular zones having circular shape, so that the images also are in the type of circular zones. So each zone in the lens having circular shape with a different radius. So passing through the different zones formed circular images with different radii. So this type of defect is called corona because the image is just like a comet. And how can we eliminate the coma? Of course, there is different methods to eliminate the coma. The first method is by using the proper stop. If the proper stop is placed in front of the convex lens at a suitable distance, which minimizes the spherical aberration. This is the convex lens where the green color is the proper stop. It has some slit. If the object is incident and rays which is incident on the stop, outer zone rays are blocked by the slit, are blocked by the stop. But the inner zone rays are is passing through the slit and incident on the convex lens. These rays passing and diverging through the convex lens and formed a single point image on the screen. So by using this method, we can eliminate the coma. And the second one is by by preparing a suitable system. By the formula, we can minimize the coma. If the refractive index of the system or lens having material having refractive index mu is equal to 1.5, if it is prepared with R1 by R2 is equal to minus 1 by 9, can reduce the coma. We know in case of spherical aberration, if mu is equal to 1.5, R1 by R2 is equal to minus 1 by 6, the system reduces or minimizes the spherical aberration. Similarly, if R1 by R2 is equal to minus 1 by 9, the system can minimize the coma. And what about thought? Abbe is the name of scientist. He derived an equation that is mu1 y1 sin theta 1 is equal to mu2 y2 sin theta 2. If any system obey this condition, minimizes the spherical aberration as well as coma, where mu1 and mu2 are refractive indices of the material of the both side of the lenses, and y1 is the size of the object and y2 is the size of the image, and theta 1 and theta 2 are conjugate angles. When any system which obey this obeys rule can minimize the coma. And how can we derive this Abbe sign condition? We will discuss now. What is Abbe sign condition? So there is a curved surface, that is I have taken AB. That is the principal axis which is passing through the center of the lens, that is at O. PP dash or PP1 is an object whose height is y1. Y1 is the height of the object PP1. If the rays which is passing through the PP1 object is incident on the curved surface AB and refracted and formed an image II1. So this is the II1 image. The height of the image is taken as y2, where mu1 is the refractive index of the medium at one side left side and mu2 is the refractive index at the right side medium. The distance of the object from the center is taken as minus u, White minus e we are taking because the object is towards the negative x-axis. The object is distance is image distance is taken as v, where v is equal to image distance, that is equal to OI, where I and R are angle of incidence and angle of refraction, and theta 1 and theta 2 are conjugate angles, where QC is the which is normal to the curved surface, and capital R is the radius of curvature of the lens. By using this, we can derive a Abbe-Sine condition. Now, we have to take triangle QPO, that is QP. There is if it is taken as theta 1, and angle that is QPO is angle QPO is taken as theta 1, and QIO is taken as theta 2. From the triangle PCP1, where this is P, this is C, this is P1, and one more triangle, that is the triangle ICI1, this is ICI1. Both triangles are similar triangles. By using this formula, y1 by y2 is equal to PC by CI. We know PC can be written as PO plus OC, and CI can be written as OI minus OC. But we know OC is equal to capital R, and OP is equal to minus U, and OI is equal to small v, and OC is equal to capital R. So that y1 by y2 is equal to R minus U by V minus R. That is taken as equation 1. But we know Snell's law is mu1 sin I is equal to mu2 sin R. That is sin I by sin R is equal to mu2 by mu1. That is useful in the next derivation. So when we apply triangle law of triangles, that is triangle PCQ, when sin law we can apply sin law of triangle from PCQ, sin theta 1 by opposite QC is equal to sin pi minus I, because this is the pi minus I, by opposite PC. We know QC and sin pi minus I is equal to sin I, and PC is equal to OC plus OP. So that sin theta 1 by sin I is equal to R by R minus U, because OC is equal to R and OP is equal to minus U. So that sin theta 1 by sin I is equal to R by R minus U. That is from the triangle PCQ. Similarly, when you have taken one more triangle QCI, how can we apply? From the triangle QCI, like a CIQ, when this is law of sine law, according to the sine law, sin theta 2 by opposite QC is equal to sin I, because sin R by this is R, sin R by IC. So sin theta 2 is same as, and QC is equal to how much? We know capital R, that is equal to sin R by QI, that is IC is equal to OI minus OC, that is equal to V minus R. According to this, sin theta 2 by sin R is equal to R by V minus U. That is one more relation. From this equation 4 and previous equation 3, when you have to take division, sin theta 1 by sin I into sin r by sin theta 2 is equal to r by r minus u into v minus r by capital R. But we know sin r by sin I according to this Snell's law, that is equal to mu 1 by mu 2. So that that is sin theta 1 by sin theta 2 into mu 1 by mu 2 is equal to y2 by y1 according to the above equation. When cross multiplication, mu 1 y1 sin theta 1 is equal to mu 2 y2 sin theta 2. This is called Aberration condition. When any system which obey this formula can minimize the spherical aberration as well as coma. So this is the about the coma. Thank you very much.